Great. Well, again, welcome everyone. Thanks for joining this webinar. Again, I'm Sam Ibar, the product manager for our database optimization or DBO product. We've got an exciting webinar today. I'm joined by three great panelists. We've got Victor Farsik, the founder of DevOps Toolkit and a prominent voice in the DevOps community. We've also got Julius Biscopso, the CTO and co-founder at Flowcore, which is a platform for data-driven applications and one of our valued early users of our database optimization product. And finally, we've got Rokas Beleficus, our Senior Director of Engineering at CAST. Our goal today is to explore the challenges of traditional caching, as well as the need for innovation in database optimization and how CAST DBO provides a powerful autonomous solution. So again, our agenda is we're going to talk about why use caching, the challenges of traditional caching, and caching made easy with DBO. Rokas, why don't you begin by providing an overview of what caching means in the context of working with the database?
Hello, everyone. Happy to have you all here. So first of all, let's step back a bit and identify like what's a cache. What does it mean? A cache is additional storage layer, more efficient one than your standard one where you store all your precious data, and usually it's more performant, like in memory cache or some other technologies which helps you to store frequently accessed data in the cache and return it faster than getting into a database or any other caching, not caching, storage technology you're using. It's a very well known term used in various applications, from CPU cache to gaming consoles, and like everything that has memory, it has some sort of cache. Today we'll be focusing on databases. And folks from the audience, if you have any questions, like during the webinar or any comments, please post them into our chat. And yeah, we want to make this as much interactive as possible, and it will happen if you will participate.
Yeah, thanks for emphasizing that, Rokas. And why don't we begin by having a little bit of a discussion about how caching is done today. Maybe Rokas, you can kind of provide a brief overview to start.
So, like from my personal experience and many of you who are here, usually cache is being implemented when you face some limitation. You don't like start doing everything, cache everything from a get-go. But once you see some slowdowns or an opportunity to add this pattern into your system, first you need to choose where you're gonna cache. Is it simple, store it in memory, custom data structure? Will it be some third-party library which you can inject into your code and use it for this specific purpose, or deploy it something like Redis in your infrastructure and store the cache there? So once you have a solution in place which can be used for storing this temporal data, then you need to identify what you want to cache. Which part of your system would benefit the most from it. Then you need to write some code in order to handle those operations. And as always, writing code, no one is perfect. We all make mistakes. You need to test it. Not maybe it will benefit you, not maybe at the first occasion, but when you refactor and so on. But that's a crucial step which takes labor hours into the process. And again, once you want to add something else, yeah, we don't need to choose the caching solution again. But yet again, you need to identify the query, rewrite the code, test it, and do the iterations uh, as often as you want to add new caching items.
Victor, I'm interested to hear from you. Kind of, is this kind of consistent with what you see when you talk to people across the industry?
Yes, and I'm kind of curious, to be honest, from the rest of the panel, because you probably know more about it than me. Do you need to rewrite code? Can you use some kind of networking solution that kind of redirect requests from the application to the cache or to the database, depending on what it is and things like that? Does it always require rewriting code?
Of course, it depends on what tools you have. Like most well-known caching tools, um, they give you lots of flexibility, but you need to customize it for it to work in your environment. Like the cache that we are building, especially for databases, it's a different kind of tool, which is very specialized. Then you can do more life quality improvements along the way, which you mentioned. But if you would ask me about like general landscape in the industry, I I think most of them require manual work.
Yeah, no. I was asking mostly because I'm not that much in that area. I was hoping that some kind of eBPF solution that would be on a very low networking level would be able to redirect. Hey, go to Redis instead of Postgres, but I'm obviously wrong.
For us, we were kind of approaching this from a different angle, where it's like we had a scaling. We needed to create a solution that was fast and scalable right away. So we ran right into the identify, instead of identify query, it was like all of the queries that we need to run need to be extremely fast, and they are distributed. So we need distributed cache right away. So that's why one of the like choose cache solutions is like if you use Redis. And in that part, you don't need to like rewrite code when you like choose a different one if it supports the Redis interface, which there are many solutions that do. But if you're doing a different like caching strategy, then you need to rewrite code. And in our case, it's like the cache is fast, but we run into issues where Redis was not fast enough. So we like then you need to identify another way of caching that, like the initial request, and then you cache the results again to speed things up. So in that case, it follows the pattern here you identified, where you identify which part you need to cache and how low level you need to go and how many layers of caching you need.
So those are some great points, Julius, and you're getting a little ahead of us because we're already highlighting the fact that there are challenges that come up when you try to do caching, and so some of these pain points that you're talking about are some of the reasons, in fact, that we've developed this DBO product. But just again, as far as implementation goes, are there any other things that people kind of need to keep in mind as far as making sure the data that's cached is current, or how long to cache it for? Can you talk a little bit more, maybe, Julius, about how you kind of came up with what the appropriate TTL, or time to live, was for your cached entries?
Yeah, that's it's a bit of like you have to do a bit of trial and error on that, because the time to live is a bit different from use case to use case. In some cases, you can have it be like 30 minutes. In others, it's like 2 or 3 minutes or 5 minutes. And in some cases, it's less than that. But there are also like layers of caching on the software side as well. So it's like you have a cache that's distributed, but you also in some cases need a cache that's locally in the application. So that's also one thing that you need to identify, where it's like where does the cache need to be? And regarding the time to live and so on, that's also it's like on those layers as well. So you're kind of compounding your issue.
And you mentioned some libraries or being compatible with Redis as a cache backup.
Yeah, it's like if you need to change the Redis instance, for example, there are a lot of database solutions that are compatible with Redis. So
But
you
you
have a
still,
bit of infrastructure to select from. That's also one thing that you need to identify, which is like what type of caching solution do you need, because it's like that also depends on the speed that you need and so on.
but you still need to implement that interface and
Yes.
how are you using that, which part of your data stream is going to the cache, which is not.
Yeah, and then also it's like, are you using clustering or non-clustering as a single instance or highly available, etc. So
I'd also be curious to know, at what point do you implement caching? If you're developing a new feature in your product or something, do you add caching from the get-go, or do you wait until you know whether there's enough, kind of
yeah,
volume?
you wait until the last moment, because it's like the simplest approach is not to cache, and then you as soon as you see that there are slowdowns and frequent hits and so on, then you go to the caching layer and then figure out what to do.
I mean, in my experience, as soon as you notice slowdowns, first you double check whether actually your schema is correct, right? Wrong indexes can fixing wrong indexes and things like that can get people a long way, even before they start implementing caching.
Yeah, Victor, 100%. Like today, I saw one index deployed in production, which improved like performance, that query performance by 20 times. And yeah, 10% of CPU usage is gone just by doing that.
Pretty awesome. All right. Well, we've kind of talked a little bit about how caching is done. Now maybe it's a good time. Let's open it up to the audience for, we've got a poll here. And the question is, what's the biggest pain point when setting up database caching? So to just give everyone a moment to respond here. We'd love to kind of get your feedback and see what the audience has to say about the challenges they see when setting up database caching.
I can't vote. It's
No,
not.
I don't think we get to
Yeah.
vote. So only the audience gets to vote. So Alexi,
I'm very curious of the results, because depending on what people vote, we will find out how far they went in caching, right? Are they just setting it up right now, or they're struggling with which queries to cache, or they're already on big scale and then are worried about other things, right?
yeah, let's see. So Alexi, do you want to go ahead and share the results? All right. So it looks like managing cache and validation is the thing that people have the most challenge with. And then in the equal share, figuring out which queries to cache and sort of setting up scalable distributed caching.
If we would have put naming in this list, it would come nicely with naming and caching validations.
That's
Most
right.
difficult things, right?
That's right. We've certainly encountered that in developing our DBO product. We've decided to focus on the caching part, and we'll let other people solve the naming thing. So let's kind of open this now for a discussion, and kind of let's talk about the challenges. I know, Julius, you started to. Maybe I'll let you begin for a moment, kind of talking about some of those challenges that you saw with setting up caching.
Yeah, so basically for us, it started with like we were implementing a GraphQL query layer to query the platform that was quite distributed. And like the queries are, it's like even if you're using data loaders and so on GraphQL, you reach to a point where are you querying enough things, then you'll hit slow points. It doesn't matter if it's indexes or not, if it's distributed enough. And in that case, we like went with Redis and trying to cache that, but then you're reaching the distribution key issue where how do you invalidate? Where do you invalidate? If you have like a clear line of, okay, you only write in this case, then it's simple enough. But it's like more often than not, you have multiple locations where you need to invalidate it because it's like you're having like you have functionality that's like it affects other functionality. For example, if you're deleting some like overall workspace or something like that, and then that has child or hierarchical relationships, then you need to invalidate those and so on. So it's like you reach like these caching issues with invalidation right away, and then it's how do you distribute the keys on the caching, and like you have to find a way, and then you have to stick with that. And then for us it was also like in some cases you just need a quick cache just to cache some results. It doesn't matter if it's not stored or retrievable or anything. Like it's just if the cache is up, then use that. Otherwise, don't just go through the normal route. And those things you also need to maintain on an infrastructure level. And if you have one giant cache, then it's like if that goes down, then you can affect multiple services. So you need multiple ones and all of those things that are difficult when handling cache. And also it's like if you have a high enough throughput and it's critical where you need multiple layers of caching, where it's one on infrastructure level, one on software level, then it's like you have to manage that as well. So it becomes difficult quite fast, especially at large throughput scales or large throughput scenarios. So we hit that quite fast to do that. And we were a small team, so it's like additional infrastructure services means more maintenance, right? Less time for product development.
I'm curious, Julius, how were you making those decisions? Were you collecting metrics or traces somewhere and then exploring those, or was
Yes,
it more artisanal?
we've used ground cover quite a while back when it was just started, and then using the power of ePVF to get all those traces and metrics and all of that. So it's like we were collecting metrics right from the get-go from all of this, so we could see the slowdowns, so we could see the issues where the issues were right away, so we could target those. But even with that help, it's still like difficult to nail all that down. In most cases, we switched caching solutions multiple times to get it fast enough,
So
and had to introduce multiple layers to get it fast enough.
Could you give a bit more insight? I'm really curious. Like, Redis seems like does a good enough job for most of the cases, performance-wise. So, what's not fast enough for you?
Well, if you as like Redis can handle like a maximum of 2 million keys efficiently, but in some cases you have more than that, especially at very high throughput levels. If you have a time to live of 5 seconds, for example, and you have 80 to 100,000 requests per second, then you're hitting those limits fast. So it's like in those cases, you need to go to solutions that can handle the amount of keys, but still like maintain the speed. And in most cases, you need to introduce additional layers of caching inside each service or each replica to get that speed down to like almost like a block level or inside the async flow, basically. So you don't have to wait, or either you pull the async requests together and then respond to that and so on. So that becomes like, especially if it's not just like amount of events that are going through the system, but the events are big, then you're getting a network layer as well. So
Okay, makes sense.
Were you ever in a situation where actually using cache slowed it down?
Yes, actually we were. We had to. That's why we had to introduce the second layer of caching on each individual service to maintain the throughput.
And was the problem there that your cache lookup was just introducing additional latency, or what was it that slowed it?
Yeah, it was simple. It's also amount of, it's like the configuration of the time to live and so on. Especially if it's like in some cases we needed to cache the API tokens, and you cannot do that for a long time because that's like a security issue. You have to be able to revoke them and so on. So it's a balancing act there as well.
I was wondering to what degree can upsizing your database resolve issues that you might otherwise resolve by caching, right? Like if you've got throwing more CPU at the database, can that address things?
Yeah, up to a point, basically. But it's like you're still reaching a point where the database is too large, where indexing doesn't help. Then you need the partitioning and so on, but that needs to like reflect in the application as well. So it's
Is
in
it
some
one big
cases
database
yeah,
for all applications, or kind of each application had its own database and it's still
each application
getting
has
big?
its own. Mm.
Yeah, like in my experience, we were facing also different issues with caching, not only at the database layer, but at the cloud providers layer, as we interact with APIs a lot, and you can get rate limited and not being allowed to do anything. But on each operation, you just need to fetch some simple data about the Kubernetes cluster, load balancer, security groups, which rarely change. So that's where we put the cache first, to not get rate limited, as once you get into that spiral, you need circuit breakers, how to get out of that, and the complexity grows. The first challenge we faced was distributed caching. As you said, like we just did in-memory caching, but when different replicas are not sharing that information, it's not that effective, etc. And then maintenance, when systems are dynamic, like you develop, change things, patterns change how your data flows. And caching is yet another thing you need to have at the checklist. Okay, I need to adjust, add more of it, or look at the metrics. Okay, this is not working anymore. Usually every year you need to reinvent what was working last year. If you're growing, it won't work today.
The issue that the audience mentions kind of as their biggest issue was cache invalidation. Victor or Ulyss, do you want to talk a little bit more about some of the challenges that people see with cache invalidation from your guys' point of view? Maybe you first.
I mean, the biggest challenge is really the figuring out what to invalidate, right? And how often to invalidate it and all those things. And it always felt to me more artisanal than really based on real data. Especially probably the biggest problem I had in the past was, you figure it out after a lot of work, and then the schema changes, and here we go again, right? I'm almost kind of disappointed that industry as a whole, that we don't have simply reliable monitoring that is actually making those decisions for us by now, right? It feels like something that shouldn't be done by people, right?
And so just to clarify, you're saying when the schema changes, then whatever write you were causing to trigger an invalidation of the cache no longer should be, or there's some different write that should be
Exactly.
validating the cache, and so then you end up serving stale data.
Exactly. Either serving stale data or wrong data or what's not. And especially, maybe if bigger organizations tend to move slower, and that is maybe not so common, but if you're talking about fast velocity companies, usually smaller, but actually things change every second week, right?
Yeah.
In some cases, every day.
Or every day. Exactly.
Yeah, Julius, do you want to mention anything about kind of your guys' experiences with invalidation? I seem to recall a story when you guys were getting started with our product where there was some invalid data that may have been served somewhere because of a cache that you actually still had in front of the DBO, if I remember right.
Yeah, that was again regarding the invalidation of a distributed cache. Like it's like you have to capture all of those points where you need to invalidate it, and then as Victor said, what do you need to invalidate? Because it's like if you just invalidate everything, it's like that's a bit inefficient to do that. Just when one thing changes, you invalidate everything. Then you're, especially in a dynamic system where you change things, then it's like, why do you have a cache?
Not only that, but once your system is used and set up to use the cache, if you validate everything, it might put such a load to the database that it just breaks, right? Because simply it's not meant to get that load.
Complexity makes things more difficult usually, even if the performance is better. But also, Victor, interesting point on that you said humans shouldn't be allowed to do this, and I was thinking that there's missing piece of dependencies, right? Like you're changing things in one part of a system which is not aware about this invalidation piece, and you could break a leg in such situations very easily, and maybe having some better ties or objects which would show, okay, this is being used for invalidation, you need to change yet another thing before changing this one, but those don't exist yet.
Yeah, we keep pushing people towards making decisions that most of the time they cannot make. If you go outside of the caching area, a simple example would be memory and CPU for your applications. Nobody knows how much they need. Everybody's forcing everybody to set it up, and we are still not in a place where actually we have systems that simply do not need it, right? Kind of figure it out, right? Theoretically, machines should be capable of doing those things, yet they're not.
Well, that seems like actually a pretty good segue for us to talk a little bit about what we're doing with our database optimizer and the way in which we're trying to use machines to make caching. So let me go ahead and share my screen again and talk for a moment about our DBO product. And what our DBO is it's an intelligent agent that's sitting between your application and your database, speaking the database protocol. It's installed within the customer infrastructure and keeps all the customer data private. Meanwhile, it's inspecting every single read and write query that passes through, allowing it to automatically identify what's cacheable and how long it should be cached for. So there's no more of this sort of trying to have to guess how long things should be cached for. Our algorithms are identifying the optimal TTLs for your data. In addition, because it's seeing all of the write traffic, it can automatically invalidate cache data when updates are made that render cached items stale. So, right, Victor, when you spoke about the problem of schema changes, again, because we're seeing the queries come through, we're able to identify, sort of the slices that are being stored in the cache data and able to invalidate it when we see a write that touches that data. As far as kind of using our product, we have this DBO component that you configure to point to your origin database and is then installed within your Kubernetes infrastructure using a script we provide. The only thing you need to do is update your application to point to the DBO's host address instead of directly to the database. And so we provide kind of this updated connection string that you use to connect to your database through the DBO. When the DBO is installed, by default, it's put in pass-through mode, which means we're simply inspecting the traffic that passes through. Immediately, the DBO begins to collect data about the queries you make, and it'll estimate how cacheable your workload is. And then when you're ready, you can put it into auto mode, and the DBO will cache whatever's cacheable, reducing load on your database and accelerating all responses served from cache to sub-millisecond response times. So kind of back to what we were saying before, there's no having to think about what to cache. You basically are future-proofing your application for anything that's cacheable will automatically be cached when the data patterns support it. This also opens the door to cost savings, either by eliminating read replicas or downsizing your database instance, or allowing you to stay on an existing database instance size for a longer period of time. Within the console, we allow you to see all of the queries that your application is sending to the database. We find customers are often surprised because they may have ORMs that are generating a lot of queries they weren't aware of, and sometimes that may introduce inefficiencies that are not ideal. For each of these queries, you're able to see the volume of each query, the hit rate that the cache is providing. We give insight into what the response times are from the database for each of these queries, so you can see which your slowest queries are. And we also let you know kind of how much database time is being used by these queries and how much of that time is being saved by the DBO. We give insights at an overall level in terms of the overall hit rate, where over the last week this application's had almost over 800 million queries, of which we've been able to serve 685 million from cache, and we've reduced the time used by the database by over 84%. For specific queries, we also give you the flexibility to override our automatic rules. So rather than automatically setting the TTL, if for whatever reason you know that there should be a fixed TTL of some time for this query, you can set it. Or alternatively, if you never want a specific query to be cached, you can turn caching off for that query.
Sam, could you expand a bit on this automatic TTL setting? It sounds like magic. Could you elaborate a bit more on that?
Yeah, I would be glad to. So basically what our algorithm does is that it's a learning algorithm that initially the first query passes through to the database. The next query, the next time we see that same query, it passes through to the database to see if the response is constant. And if it's constant, then we know we're able to cache it. And we hydrate the cache with that information and set a TTL based on the arrival rate of the queries. And we will extend or decrease that TTL based on the stability of the responses to that query. So over time, that TTL will adjust to kind of be that ideal time for the query that you have.
Is the invalidations involved and write queries in setting the TTL?
So right. So when we see write queries, that will automatically invalidate the cache at that time. So when there's a write, that will stop. Will evacuate the cache. The next read request of that query will go to the database and rehydrate the cache, and our algorithm is updated based again on the timing of how long we saw a stable responses to the query and kind of then when we're seeing invalidations.
I think the audience would benefit of an example. Now we have a query here on the right side, and this is a read query selecting from different columns, joining them. And what would happen, Sam, if I would insert some data not exactly into the same columns, but let's say product image into product image column.
With
So-
a different ID or same?
I can take sort of both examples, right? What we attempt to do is we attempt to identify based on that right query what the narrowest amount of information that we can invalidate is, so that we're able to serve as much as possible out of cache. But we take a conservative approach, which is to say that if there's an update that we think might be touching this query, we'll invalidate the cache, because at this point we're trying to optimize based on not serving stale data. In the future, one of the enhancements we plan is kind of to give the customer the option, because there's certainly, one of the things we hear is that there are times where, look, I might not care if this data is a little bit stale, and so I'm happy to, perhaps if you're setting a fixed TTL of 10 minutes, you're happy to have stale data served during that 10-minute window. And in that case, we wouldn't invalidate even if we've seen the invalidation. But does that address your question, Rokas and Victor?
Yeah.
Again, just also to mention, all of this DBO component is installed in your infrastructure. We get anonymized metadata up to our console so that you can get these insights, but all of your query responses and the parameter values, none of that comes outside of your infrastructure. Rokas, maybe this would be a good time for you to kind of talk a little bit more about kind of what's going on under the covers and kind of what the architecture of the DBO looks like.
Yeah, thanks, Sam. You mentioned very important thing that I wanted to tell when talking about architecture. Like first-class citizen and making architecture decisions was data safety. Like that's the most important thing. If you are putting some third-party tool in the middle of your data traffic, you might have sensitive data or private data. There are tons of reasons of being worried about that. So we needed to find a solution where it would be smart enough to do all the action inside your parameter, but not heavy enough to overload your infrastructure. And at the same time, we wanted to have a unified place where you can access all that information. And you just saw that in Sam's presentation of our console. And what Sam showed you was only one logical database. If you would have a fleet of databases, you could have his data all in one place and go through it easily in one single screen. So what you're seeing in the diagram as the most important thing is that the proxy with the AI-backed query processor is hosted in your infrastructure. So it acts as a proxy component where, as previously Sam showed you, one single URL link that you get and you point it to the deployed proxy and application. There's no need to do any other modifications for your application. So once it's redirected through the proxy, you get to see all those queries. You can turn on cache automatically everything or play with the settings on the go. Another important thing to mention is what about authentication? Like, do I need to pass credentials to it, or does it know my passwords to a database? Short answer is no. It acts as a proxy, and when an application sends authentication request, it just redirects it straight to the database. That's where the authentication happens, and we don't see and store any of the database credentials. Once the session is established, we will use that session and act as a man in the middle, responding with cached items when needed, when we have those, or letting the traffic through in a database when we are missing. Also, the third thing and the last thing that I want to mention is, as you saw, there's proxy and query processor. Those are two components. The proxy piece is stupid simple. Like, it just needs to be performant and to handle all the volume that Ulyss was mentioning about before. So it just checks, is there a cache or not? And like, it asynchronously consults with the query processor of what should it do with this query next time. So it shares that this query came. The query processor is the decision maker and come back to the proxy with what to do next in milliseconds. And the metadata which is being sent to console is, as Sam mentioned, anonymized just for informational purposes. And all those queries are stripped out of sensitive data. Only the column names, table names are being seen. So the operator can have all the context. So these are the most important items of architecture. It's being deployed into Kubernetes clusters primarily using Helm. So all the standard stuff in nowadays DevOps space. Julius, maybe you could share a bit like how the onboarding process went, like where were the easy parts, the hard parts, or some insights from the console, what Sam showed before would be useful as well.
Yeah, sure. So I think for us, it's like we're small startup. We're moving fast, but we want to like try new things. So we're not like afraid of that. But at the same time, what made it easy for us to try DBO, the same as with CAST AI, was that you can turn it on without any cost, and you can see the results right away without having to like activate the cache or disrupt your application or applications or platform. And we basically had CAST running for like half a year before we turned it on. And with the DBO, we had it running for like 2 weeks before we turned the automatic caching on, just to see like what traffic we were getting through the system. And of course, we were like one of the first ones to try it. So like onboarding databases was not as easy as it is now, but it was still just a Helm chart to install and then an API call to configure. While now it's a lot easier just to use the UI, just to create like the registered databases and so on. And you get most of the Helm commands from the UI as well, so that helps, especially in speeding things up. But I think what we've experienced is more that is like the caching layer has become a lot simpler while using this. We are already at V2 for most of our services, and in the V2 services we don't have to worry about caching. In some cases we still need the software level cache because we are at nanosecond response times in some cases that we need to cater to, but it means that we don't have to have these like Redis conversion layer in front, because it's just a database, and then you query the database like you normally do, and you get that cached response back. That's as fast as Redis. So it's like that part has been very easy to set up, and especially just configuring the connection string. That's it. Then you're up and running. You don't have to worry about anything else. So I think that's it's like it's a bit of a no-brainer to try, at least if you're at that point where you're seeing that, okay, you need to have caching or you have a complex caching solution, then it's a simple way to try it, just to install it and then see what you're missing basically, or what you're hitting basically.
Yeah, I would just emphasize, and I think Julius started before we had even the UI for the ability to onboard certain sorts of databases. But at this point, right, we support any Postgres instance hosted anywhere, whether it's an RDS, Aurora, or Google Cloud SQL, or if you have your own Postgres instances with running in a Kubernetes cluster. It's very simple to set up and configure, and so yeah, it's been great to have you as a partner, Julius, in the early development of it, and I think we're glad to make it easier and easier for customers to onboard and use.
And also the console just gives you quite a lot of insights into the how cacheable your data actually is, and also the queries and how often they're hit and so on. There's a lot of information that's good to have without having to rely on yet another observability platform. So we're using Ground Cover for us, and that does not have like the full suite of something like Datadog or something like that. So the console in its own is quite a good observability tool to have to monitor your metrics.
Victor,
Awesome.
maybe you have any questions, insights, like from what you've seen, any thought popped into your mind?
I mean, I'm a Kubernetes freak. My first thought that popped to my mind when you showed that you can choose what is manual and what is out, or whether I could do that with CRs or no. That's always my first thought. I don't like UIs, kind of. I always think, okay, can I operate this without a UI?
Yeah, ClickOps, right?
Yeah.
That's like settings in the UI is just configuration, and we have a planned infrastructure as code movement coming for configuring this.
Nice.
Great. Well, being mindful of time, let's go ahead and walk forward. And I just kind of wanted to just spend a minute kind of giving the context of where DBO fits within the broader CAST platform. So, for those of you who are new to CAST, CAST is the leading application performance automation platform. Unlike traditional solutions that are just monitoring clusters and providing recommendations, CAST is able to leverage advanced machine learning algorithms and continuously analyze and automatically optimize your clusters in real time to cut your cloud costs, improve application performance, and boost DevOps efficiency. We designed our platform for comprehensive application performance automation, including Kubernetes cluster optimization, cost monitoring, auto scaling, security, workload optimization, and LLM optimization. DBO as a piece of this puzzle is providing the autonomous caching that we spoke about, giving you zero code deployment with a transparent proxy, an AI-driven intelligent cache to optimize your caching and invalidation, the flexibility to have a pass-through mode, the auto mode where we're doing whatever we can, or a manual mode where you can choose just which queries you want cached, and then the observability features that Julius was talking about. And what we found is that teams are seeing significant reductions in database load, often between 30 to 80%, query speed improvements, 10 times or more faster for compute intensive tasks, and really just simplifying the whole caching process, making it much easier to implement caching to improve your application and reduce your database load. As far as the future of DBO, we see our caching solution as one of three legs of a stool. As we work to expand caching to include additional database engines beyond Postgres and MySQL, which are already supported by DBO, We're also building capabilities to automate database administration tasks, as well as to rewrite database queries as part of the broader application performance automation initiative. On the DBA side, Julius, I don't know if you've heard this yet, but we were kind of talking about indexes before. Our first initiative there is around index advising and helping people identify indexes that they don't have that may improve performance, or indexes that they do have that they shouldn't have that they could improve their performance by their elimination. I wondered, are there any other features that you'd be particularly eager to see, Julius, either within the caching realm or kind of more in the broader Postgres optimization realm?
Well, I think with the index advisor, that's quite good. But I think something around like the PG vector is becoming quite popular. So something about vectorization and so on to get insights into that, because that's like that will become like a very large part of installations coming forward. So that's something that's
You mentioned PG
that will
bound
be a PG vector.
or PG vector. Okay.
Yeah.
Okay, well, we'll love to follow up with you and hear more about it again, as we're eager to think about the areas in which we can help, use intelligent automation to, make working with your databases simpler. I know we've kind of addressed a few questions that we've seen in real time here, but if there are any additional questions from the audience now, we'd love to answer any that you have. So now would be a great time to go into the chat or into the Q&A panel and post any questions that you might have. While we're waiting for a moment, Victor, I don't know, do you have any other? Again, this is new to you. We had Einstein not really introduced this to you before. Any questions you have about what we're doing with DBO here?
One question I would have, that's probably future roadmap, I guess, question. Can I get the data? Can I get the data that I would be seeing in your console and plug into, let's say, Grafana or something like that? Because one of the problems is that you end up having to go to 75 different places to see the information of the system itself, and having it together with the rest of the data would be very useful.
Sam, I'll take that. As a platform, we are actually doing these things already, just for
nice.
different set of products. Like we are exposing Prometheus compatible endpoints, which you can scrape and ingest into your Grafana dashboards or whatever you like. And that's what we show there is business metrics. For example, for Kubernetes cost optimization, it's like how many nodes we added, how fast we are processing the data, and insights into how the system is doing and if it's healthy. So you not only can see the data, but set up alerts, notifications into your existing operations flows. So, and with DBO, we'll follow that for sure. But the more important thing first is to solve the problems, then build the dashboards.
Makes sense.
We do have one more question here from an attendee. When it comes to intelligent caching, is DBO able to cache and validate complex stored procedure queries? Rokas, I don't know if you want to address that or not. I can kind of talk to.
Oh, now we're going to have a discussion whether anybody should use stored procedures.
Let's save that part for another conversation.
I'd say if it's a repeating query which is returning the same response, like yes, we'll be able to cache it. The complexity of the query doesn't matter in order to be able to cache it or not. It's more about it being repetitive and not having too many invalidations between the reads. Because if you write, read, write, read, write, read, like you'll always be invalidating that data, and
It
won't be efficient.
And the other thing I'll emphasize there is that if the underlying data is changing, our algorithm will even if we are missing an invalidation because we aren't able to identify what tables are actually being touched by that stored procedure, the fact that the underlying data is changing, our algorithm will automatically recognize that it shouldn't be caching that as well. And so, we sort of take this belt and suspenders approach to not caching things that shouldn't be cached, either because there's an invalidation or because there isn't a stable payload in the response.
I also see Alexander asked what database engines are currently supported. So currently it's Postgres and MySQL. And potentially MongoDB is the next one. We see the most demand for it. And we base our roadmap based on the demand from the market, what's being mostly used, and where we can create the most value at.
Super. Well, this has been really great. I want to thank everyone for attending today's session. Thank you to Victor and Julius and Rokas for this panel discussion. It's really been great. You can go ahead and try this out yourself for free at cast.ai/get-started, or you can take a picture of the QR code on the right and book a demo. And again, we're eager to have you use this product and make your caching journey easier. Again, thanks again to everyone for being part of this.
Yeah, likewise.